Imagine for a moment that someone handed you the keys to the largest, most powerful mobile crane in existence. A mechanical beast worth $15 million, capable of hoisting entire sections of bridges into the air. A machine so massive that it requires a convoy of trucks just to transport its disassembled parts from one construction site to another. And then asked you to use this marvel of modern engineering to lift and precisely position 3 limestone blocks, each one weighing more than 800 tons, fitting them together so perfectly that you couldn't slide a credit card between their edges, and doing so in a way that would allow these stones to remain locked in place for thousands of years, surviving earthquakes that would level modern buildings, enduring the slow grind of millennia without mortar or metal reinforcements to hold them together. Now imagine being told that you need to accomplish this feat without the crane, without hydraulics, without steel cables rated for impossible loads, without computer-assisted precision instruments, without any of the technologies that we consider absolutely essential for moving objects that weigh as much as a fully loaded naval destroyer, and that you need to do it using only the tools and knowledge available to people who lived so long ago that the pyramids of Egypt would have been relatively recent constructions by comparison. And you begin to grasp the fundamental absurdity of what stands today in the Beqaa Valley of Lebanon, in a place called Baalbek, where 3 stones sit in silent defiance of every reasonable explanation we can offer. These are not the largest stones ever quarried by human hands. That distinction belongs to another block that still rests in the same ancient quarry about a quarter mile from where the trilithon stands. A single piece of limestone so preposterously massive that it earned the name Stone of the Pregnant Woman from local legends. A monolith that weighs somewhere in the neighborhood of 1,000 tons, which is to say that it weighs approximately as much as 300 fully grown African elephants standing trunk to tail. Or, if you prefer a more industrial comparison, roughly equivalent to 3 Boeing 747 aircraft, loaded with passengers, luggage, and enough fuel to fly halfway around the world. All of that weight concentrated into a single block of stone that was somehow cut free from the living bedrock, shaped with precision that would impress a modern stonemason, and then, apparently, abandoned in place, as if the ancient builders simply looked at what they had created, shrugged with the cosmic indifference of beings who regularly accomplished the impossible, and walked away to carve something even more audacious. The stone of the pregnant woman sits there still, partially freed from the quarry floor, its edges sharp and deliberate, a testament to intention and capability that modern engineers examine with the kind of uncomfortable silence usually reserved for phenomena that shouldn't exist according to everything we think we know about the limits of human achievement in the ancient world. But it's the trilithon itself, those 3 blocks that actually made it to the temple complex, and now form part of a foundation that supports Roman temples built thousands of years later, that truly captures the imagination and simultaneously assaults our sense of what should be possible. Because unlike the abandoned stone in the quarry, these 3 megalithic blocks were somehow transported from their birthplace in the earth, moved uphill across uneven terrain for approximately 3/4 of a mile, lifted to a height of 20 feet above ground level, and positioned with such mathematical precision that their combined length spans over 300 feet of foundation wall, creating a platform so stable and so perfectly engineered that it has survived earthquakes measuring 7.5 on the Richter scale. Catastrophic events that reduced nearby cities to rubble, while these ancient stones barely shifted from their original positions. Each individual block measures roughly 64 feet in length, 14 feet in height, and 12 feet in width. Dimensions that fail to adequately convey the overwhelming physical presence of standing before them, of placing your hand against limestone that has been in exactly that position since before the fall of Rome, before the birth of Christ, before the writing of the Hebrew Bible, before Homer sang of Troy, stretching back into a past so remote that we genuinely don't know who put them there, or why they possessed the capability to do so, when civilizations that came thousands of years later, civilizations with written languages and sophisticated mathematics and organized labor forces, could barely manage to stack stones a fraction of this size. The weight of these stones, expressed in the cold mathematics of tons and pounds and kilograms, somehow fails to communicate the reality of their mass. The way that numbers on a page can tell you that the sun is 93 million miles away, without making you feel the true vastness of that distance. So perhaps it helps to think of it this way. If you gathered together 150 African elephants, adult bulls in their prime, each one weighing between 5 and 6 tons, and if you could somehow convince all of them to stand perfectly still on a single stone block, you would approximate the weight of just one of the trilithon stones. And you would need to repeat this elephant stacking exercise 3 times to represent the complete trilithon. 450 elephants in total, more elephants than you would find in many national parks. All of that living, breathing weight concentrated into 3 pieces of carved limestone that had to be moved, lifted, and positioned with a margin of error measured in millimeters rather than meters. Modern cranes, the kind that cost more than most, people will earn in several lifetimes, the kind that require specialized engineers to operate and teams of workers to assemble, the kind that represent the absolute cutting edge of our contemporary understanding of leverage and hydraulics and materials science. These technological marvels can lift comparable weights, but only under ideal conditions, on level ground, with extensive preparation, with computer modeling to calculate stress points and load distribution. And even then, the operation is considered extraordinarily risky. The kind of lift that makes insurance companies nervous, and engineers double-check their calculations in the middle of the night, lying awake with the knowledge that a single miscalculation could result in hundreds of tons of metal and stone crashing to earth with enough force to crater the ground and destroy everything in the immediate vicinity. And yet, somehow, some group of people, or beings, or whatever intelligence was responsible for the megalithic platform at Baalbek, managed to accomplish this feat not once, but repeatedly, creating a foundation composed of multiple courses of massive stones, with the trilithon forming just one part of a larger complex that includes dozens of stones weighing between 300 and 400 tons each, blocks that would themselves be considered engineering marvels if they weren't dwarfed by their even larger companions. All of them fitted together with the kind of precision that makes you wonder whether the ancient builders possessed some fundamental understanding of stone and weight and physics that we have somehow lost or forgotten in our rush towards steel and concrete and computer-aided design. The Romans, who eventually built their temple complex on top of this far more ancient foundation, were themselves master engineers and builders. The same civilization that constructed aqueducts spanning miles of countryside, that created concrete that remains superior to modern formulations in certain applications, that built the Colosseum and the Pantheon, and roads that still carry traffic 2,000 years after Roman legions marched across them. And yet, when these accomplished builders arrived at Baalbek and saw what already existed there, they apparently took one look at the megalithic platform and decided that trying to replicate or even match it would be an exercise in futility, choosing instead to simply build on top of it, using their own much smaller stones, though calling them smaller seems absurd when some of the Roman blocks themselves weigh upwards of 60 tons, which would be considered impossibly massive in almost any other context, but appears almost modest compared to the foundation beneath. The trilithon stones fit together with such perfection that running your fingers along the joints between them reveals almost no separation, no gap, no space where mortar might have been applied to help bond them together, because there is no mortar, no adhesive, no binding agent of any kind, just stone upon stone, held in place by weight and precision and an understanding of engineering principles that allowed ancient builders to create structures that would remain stable for thousands of years, without any of the techniques we consider essential for permanent construction in the modern world. Contemporary stonemasons, people who have spent their entire professional lives working with rock and learning the secrets of how different types of stone can be shaped and fitted together, these experts examine the trilithon and struggle to explain how such precision was achieved. Because getting 3 blocks this size to align perfectly would be challenging enough if you could work on them in place, measuring and adjusting and fine-tuning their positions with modern instruments. But the evidence suggests that much of the shaping and fitting was done before the stones ever left the quarry, which means that whoever carved these blocks possessed not only the physical capability to move them, but also the mathematical and spatial reasoning to know exactly how they would fit together once they arrived at their final destination, accounting for every irregularity in the bedrock beneath, every slight variation in angle and alignment, calculating all of this in advance, with a margin of error so small that we can barely detect it with our precision instruments thousands of years later. The implications of this precision, when you really stop to consider them, become increasingly difficult to reconcile with our understanding of ancient capabilities and the supposed linear progression of human technological achievement. Because we tell ourselves a comfortable story about how civilization develops, how we gradually accumulate knowledge and tools and techniques over generations and centuries, building on what came before, always moving forward and upward toward greater sophistication and capability. And yet, here stands evidence that suggests this narrative might be, if not entirely false, then at least incomplete, missing crucial chapters where human knowledge and ability apparently peaked at levels we struggle to match even now, only to somehow recede and vanish, leaving behind monuments that we can study and measure and photograph, but cannot truly explain. Not in any way that doesn't require us to radically revise our assumptions about what ancient peoples could and could not accomplish. We can split atoms and edit genes and send probes to the outer reaches of the solar system, but we cannot, with any real confidence, explain how blocks weighing 800 tons each were moved and lifted and positioned with millimeter precision by people who supposedly lacked wheels suitable for heavy transport, lacked steel tools capable of cutting limestone with the precision evident in these stones, lacked written mathematical systems sophisticated enough to calculate the structural loads involved, lacked every advantage we consider essential for this kind of construction. And yet there the stones sit, massive and silent, and utterly indifferent to our confusion and our carefully constructed theories about the limits of ancient technology. The question of who built the megalithic platform at Baalbek remains officially answered by the vague attribution to various ancient civilizations, with Roman construction on top of possibly Phoenician or earlier foundations. But this explanation has the hollow ring of something we tell ourselves, because the alternative, admitting that we genuinely don't know, that we cannot explain it with our current understanding of ancient capabilities, would require a humbling admission that our timeline of human achievement might be wrong, in ways that would fundamentally challenge how we think about the past and our place in the long sweep of history. The Romans didn't build the foundation. That much seems clear from the archaeological evidence and the stark difference in construction techniques between the megalithic platform and the Roman temples above. But if the Romans, with all their engineering prowess, didn't do it, and if the civilizations that came before them were supposedly less technologically advanced rather than more, then we find ourselves facing a mystery that suggests either our understanding of technological progression is fundamentally flawed, or something existed in the ancient world that left behind almost no trace except for these impossible stones. These monuments to a capability that shouldn't exist, according to everything we think we know. And perhaps that's why standing before the trilithon feels less like visiting an archaeological site and more like encountering physical evidence of a cosmic joke. A reminder that, for all our modern sophistication and our satellite imagery and our computer models and our certainty about how the ancient world worked, we still cannot explain how someone moved 3 stones that weigh as much as naval destroyers and fitted them together with precision that would challenge our best engineers even today. Which leaves us with the uncomfortable possibility that we might not be as clever as we think we are, that perhaps we're not standing at the pinnacle of human achievement looking back at our primitive ancestors, but rather standing in the valley, looking up at heights we haven't yet managed to climb again. And that thought, more than anything else, makes these stones dangerous to our comfortable narratives about progress and civilization and the inevitable forward march of human capability. Because if they could do this, and we still can't figure out how, then what else were they capable of? And more importantly, what else have we forgotten? There exists a particular kind of silence that falls over construction professionals when you ask them to estimate what it would take to recreate the megalithic platform at Baalbek using the tools and methods supposedly available to ancient builders. A silence that stretches uncomfortably long as these experts in moving heavy objects and calculating structural loads run through mental calculations that inevitably lead them to the same conclusion. It cannot be done. Or at least, it cannot be done in any way that makes sense, given our understanding of physics and engineering and the limitations of human and animal labor. And this silence becomes even more pronounced when you point out that someone clearly did do it. That the stones are there, right now, sitting in their precise positions after thousands of years, which means that the impossible happened. Regardless of whether our mathematics and our crane specifications and our computer models say it should have been achievable. Modern construction companies, the kind that build skyscrapers and suspension bridges and move massive pieces of infrastructure across continents, have been approached with hypothetical contracts to recreate Baalbek's foundation using only ancient methods, no modern machinery, no steel cables, no hydraulic lifts, nothing that wouldn't have been available to builders working in the Bronze Age or earlier. And these companies, after careful consideration and extensive internal discussion, have quietly declined even to provide serious estimates for such work. Not because they're unwilling to take on challenging projects, but because their engineers cannot conceive of a method that would actually accomplish the task without either killing workers in catastrophic accidents or simply failing to move the stones at all, which represents a kind of professional admission that we've reached the limits of our ability to explain the past, using the comfortable assumption that ancient peoples were simply less capable versions of ourselves, working with inferior tools toward the same goals we pursue today. The problem begins with the most basic question of all. How do you lift 800 tons of limestone off the ground in the first place? Because lifting even a fraction of that weight requires equipment that operates according to principles of leverage and mechanical advantage that should, in theory, be achievable with wooden beams and rope and enough human labor. Except that when you actually run the calculations, when you factor in the breaking strength of natural fiber ropes and the load-bearing capacity of wooden levers, and the number of workers who could physically fit around a stone of these dimensions, pulling in coordination, the numbers simply don't work out in any configuration that wouldn't result in snapped ropes and shattered timbers, and workers crushed beneath stones that fell from heights when the inevitable structural failure occurred. The largest mobile crane in operation today, the Liebherr LTM 11200-9.1, represents the absolute pinnacle of modern heavy lifting technology. A machine that cost approximately $15 million to develop and manufacture, equipped with computerized load monitoring systems and hydraulic cylinders capable of generating forces that would have seemed like divine power to ancient builders. And this technological marvel can, under optimal conditions, with extensive preparation and planning, lift approximately 1,200 tons to a limited height, which means it could, theoretically, handle one of the trilithon stones, though just barely. And even this comparison misleads, because the Liebherr requires a massive support structure to be assembled before any lift can occur, including outriggers that extend to create a stable base, counterweights that must be precisely calculated and positioned, and a foundation capable of supporting not just the weight of the stone being lifted, but the combined weight of the crane, the stone, and all the forces generated during the lifting operation. Forces that multiply exponentially as the load rises higher from the ground. But here's where the comparison between ancient and modern capabilities becomes truly absurd. The Liebherr crane, for all its impressive capacity, operates on perfectly level ground that has been surveyed and prepared specifically for the lift, with engineers using laser levels and computer models to ensure that every aspect of the operation falls within acceptable safety parameters. And even then, lifts of this magnitude are considered extremely high-risk operations that require permits, and inspections and insurance policies that cost more than most people earn in a year. Whereas the ancient builders at Baalbek somehow moved their 800-ton blocks uphill over uneven terrain for approximately 3/4 of a mile from the quarry to the temple site, navigating slopes and irregularities in the landscape that would challenge even modern wheeled transport with shock absorbers and hydraulic suspension systems. And then they lifted these blocks not to a minimal height, but to a position 20 feet above the ground, fitting them into a wall with such precision that the joints between stones remain nearly invisible after thousands of years of weathering and seismic activity. The engineering challenges multiply when you consider that modern cranes achieve their lifting capacity through hydraulic systems that can generate enormous pressures in confined spaces, using steel components that can withstand stresses that would pulverize wood or snap bronze tools. And these systems are monitored continuously by computers that can detect minute variations in load distribution and automatically adjust to maintain stability. Whereas ancient builders would have been working without any of these technological advantages, relying instead on pure mechanical principles and human coordination, and some method of elevation that has left no trace in the archaeological record. No remnants of massive wooden scaffolding, no evidence of ramp systems that would have needed to be enormous to handle loads of this magnitude. Nothing but the stones themselves, sitting in their final positions, as if they simply materialized there through some process we cannot fathom or replicate. The precision problem compounds the lifting problem in ways that become increasingly difficult to explain the more closely you examine the actual construction of the megalithic platform. Because it's not enough to simply move massive stones from point A to point B. The blocks had to be positioned with such exactitude that their edges align within tolerances measured in millimeters, creating joints so tight that you genuinely cannot slide a piece of paper between the stones, let alone insert the blade of a knife or any other implement thin enough to test the gap. And achieving this level of precision with modern equipment requires laser measuring tools and computer-aided surveying equipment, and the ability to make minute adjustments to position using hydraulic systems that can move massive weights in increments so small they're almost imperceptible, shifting a stone weighing hundreds of tons by fractions of an inch until it settles into perfect alignment with its neighbors. Modern stonemasons, when asked to duplicate this kind of precision on a much smaller scale using hand tools, spend weeks or months on individual blocks, carefully measuring and remeasuring, making tiny adjustments to the cutting angles, test-fitting pieces multiple times before committing to final placement. And even then, the results rarely achieve the seamless integration visible in ancient megalithic construction, which suggests that whoever built these structures either possessed measuring instruments far more sophisticated than the copper and bronze tools we find in archaeological contexts, or they understood stone and geometry in ways that allowed them to work with a kind of intuitive precision that modern craftspeople, for all their training and experience, cannot replicate, even when they're trying specifically to do so as a demonstration of ancient techniques. The quarry-to-site transportation problem presents perhaps the most vexing challenge of all, because moving an 800-ton block across flat, level ground would be difficult enough, requiring either an enormous number of workers pulling in perfect synchronization, or some method of reducing friction to the point where the stone could be slid or rolled without requiring forces beyond what human and animal labor could generate. And various experiments have attempted to demonstrate that ancient peoples could have accomplished this, using log rollers or sleds lubricated with water or oil. Except that these experiments invariably use stones that weigh perhaps 10 or 20 tons at most, which is to say, they use blocks that are roughly 1/40th the size of the trilithon stones. And the physics of moving objects doesn't scale linearly. Doubling the weight of a stone more than doubles the difficulty of moving it, because friction increases, the number of potential failure points multiplies, and the coordination required among workers becomes exponentially more complex as the crew size grows beyond a certain point. Moving the trilithon stones from their quarry to the temple site meant navigating uphill terrain, which introduces gravitational forces that work against the movers, requiring not only the ability to pull the stone forward, but also the capacity to prevent it from sliding backward whenever forward momentum ceased, and preventing an 800-ton stone from sliding backward on a slope would require braking forces that could only be generated by massive anchoring systems or enormous numbers of workers maintaining constant tension on restraining ropes. And all of this would need to happen while simultaneously coordinating the forward-pulling crews and ensuring that the stone remained balanced on whatever conveyance system was being used to transport it. Because if the stone tilted or shifted unexpectedly on a slope, the resulting momentum would be absolutely unstoppable, a cascade of disaster that would crush equipment and workers and send hundreds of tons of limestone tumbling downhill in a catastrophe that no amount of rope or muscle could prevent. Engineers from various disciplines have proposed numerous theories for how the ancient builders might have accomplished this transportation feat, including elaborate ramp systems that would have required moving almost as much earth and stone as the blocks themselves weighed, or sophisticated pulley arrangements that could multiply human force but would need anchor points capable of withstanding loads that would uproot trees or crack bedrock, or even more exotic proposals involving counterweight systems or water-based flotation methods. But each of these theories encounters the same fundamental problem. When you actually calculate the forces involved, when you factor in the strength of available materials and the physical limitations of human workers, and the need to maintain control throughout the entire operation, none of these methods quite work, or at least they don't work without introducing additional technological requirements that we have no evidence existed in the ancient world. And so we're left with a situation where the most honest answer an engineer can give is that they don't know how it was done, which is an uncomfortable admission for a profession that prides itself on solving exactly these kinds of problems, on figuring out how to move heavy objects from one place to another safely and efficiently. Because if modern engineers, with all their knowledge and tools and computer modeling capabilities, cannot devise a plausible method for accomplishing what ancient builders clearly did accomplish, then either our understanding of ancient capabilities is drastically incomplete, or something else was at work that doesn't fit into our current framework of what was possible in the distant past. The experiments that have been conducted to test theories of ancient megalithic construction provide an instructive lesson in the gap between what we think should be possible and what actually proves achievable. Because these experiments, conducted by archaeologists and engineers and enthusiasts seeking to demonstrate ancient techniques, have managed to move stones using methods that, theoretically, could have been available to Bronze Age builders. Teams of workers pulling on ropes, wooden rollers, lubricated sledges, various forms of levers and inclined planes. But the stones moved in these experiments weigh somewhere between 1 and 20 tons, which makes them impressive demonstrations of human coordination and effort, but tells us almost nothing about how to scale these methods up to handle blocks that are 40 or 50 times heavier. Because the relationship between size and difficulty is not linear, but exponential. And a technique that works adequately for a 10-ton block might be completely useless for a 400-ton block, let alone an 800-ton monolith. Like those in the Baalbek Trilithon. The experiments with Easter Island Moai statues, which weigh between 10 and 80 tons, and represent some of the most extensive practical research into ancient stone-moving techniques, have shown that relatively small teams of workers using ropes and wooden implements can indeed move multi-ton stones across considerable distances, rocking them forward in a walking motion or dragging them on wooden sleds. But even the largest moai transported to their platforms weigh less than 1/10 what a single trilithon stone weighs. And the Easter Island experiments required multiple attempts, frequent stops for repairs when ropes broke or wooden components failed, and occurred on terrain that, while not perfectly level, was far more forgiving than the uphill route from Baalbek's quarry to its temple platform, which suggests that scaling up these techniques to handle the truly massive megalithic blocks would have required not just more workers, but fundamentally different approaches to the entire problem of transportation and placement. What makes the Baalbek megalithic platform particularly confounding is that it demonstrates not only the capability to move impossibly large stones, but also the ability to work with them in ways that suggest a sophisticated understanding of structural engineering and earthquake-resistant design. Because the foundation, despite its enormous weight and the precision of its fitted stones, actually incorporates features that allow it to flex slightly during seismic events, rather than cracking and shattering the way a completely rigid structure would. And this kind of earthquake-resistant design requires understanding how forces propagate through stone during ground movement, how different shapes and arrangements of blocks can absorb and dissipate energy, how to create structures that are both massively stable under normal conditions and yet flexible enough to survive extraordinary stresses without catastrophic failure. Modern earthquake-resistant design uses computer modeling to simulate seismic forces and calculate how structures will respond, employs materials with known stress-strain characteristics, incorporates damping systems and flexible joints specifically engineered to absorb movement. And even with all these technological advantages, modern buildings still suffer damage or collapse during major earthquakes. Whereas the Baalbek platform has survived multiple seismic events measuring above 7 on the Richter scale, events that reduced nearby structures to rubble, while the ancient megalithic blocks barely shifted from their original positions, settling perhaps a few millimeters, but maintaining their structural integrity and their precise alignment in ways that confound engineers who understand exactly how difficult it should be to create structures with this level of seismic resilience, especially when working with stones so massive that any significant movement would generate forces capable of shattering the blocks themselves or crushing anything caught between them as they shifted. The absence of tool marks or evidence of the implements used to quarry and shape these massive blocks adds another layer of mystery to the engineering puzzle. Because cutting limestone, even relatively soft limestone, like that found in the Baalbek quarry, requires tools hard enough to abrade or chip away the stone. And while copper and bronze tools can certainly work limestone, they do so slowly and with considerable effort, leaving behind characteristic marks where the cutting edge contacted the stone surface. Yet, many of the megalithic blocks show surfaces that appear almost polished, edges that are sharply defined, without the irregular chipping you'd expect from hammering with soft metal tools, and faces that are flat to a degree that would be challenging to achieve even with modern diamond blade saws and precision grinding equipment. Which raises the uncomfortable question of whether the ancient builders possessed tools or techniques for working stone that we haven't discovered in the archaeological record, perhaps because such tools were made of materials that degraded completely over the millennia, or perhaps because they employed methods that didn't require tools in the way we understand them, working stone through processes we haven't yet considered because they fall outside our framework of what stoneworking technologies should look like, based on our assumptions about the linear development of human capabilities and the tools available at various points in our supposed progression from primitive to advanced civilizations. And so, we arrive at the deeply ironic situation where humanity can build particle accelerators that probe the fundamental nature of matter, can engineer computer chips with transistors measured in nanometers, can send spacecraft to land on comets billions of miles from Earth, and yet we cannot, with any real confidence, explain how people who supposedly lacked even the wheel for heavy transport managed to move, lift, and precisely position stones that would challenge our largest cranes and most sophisticated construction equipment, which suggests either that our timeline of technological development is missing crucial information about what ancient civilizations actually knew and could accomplish, or that we've fundamentally misunderstood something about the nature of these structures and the methods by which they were created. And either possibility demands that we approach these ancient monuments not with the comfortable assumption that we understand them better than their builders understood what they were doing, but rather with the humility of people confronting evidence that our ancestors, or whoever built these structures, possessed knowledge and capabilities that we have not yet recovered or replicated. And until we can actually demonstrate a method for moving 800-ton stones with Bronze Age technology, until we can show, rather than theorize, how this was accomplished, we should perhaps admit that the stones at Baalbek represent a challenge not just to our engineering capabilities, but to our entire understanding of what was possible in the ancient world. And that admission might lead us to ask what else we've gotten wrong about the past and the peoples who inhabited it. Questions that become all the more pressing when we realize that the engineering mystery of how these stones were moved is only the beginning of the puzzle, because the deeper mystery lies in why anyone would undertake such a monumentally difficult task in the first place. What purpose these massive stones served that made their transportation and precise placement worth the enormous expenditure of resources and human effort, and whether the foundation they created was meant to support temples and structures we can still see, or whether those Roman and later constructions were merely afterthought, built atop something far more ancient and far more significant than we've yet understood. Questions that lead us inexorably toward the historical record and what it does and doesn't tell us about who built this impossible platform, and why they left behind no clear explanation for how they accomplished what should not have been possible. The Romans were obsessive documenters of their own achievements, leaving behind detailed records of everything from the construction techniques used in their aqueducts to the dietary habits of their emperors, from the strategic planning of military campaigns to the scandalous affairs of senators and the architectural specifications of their public bathhouses, creating a historical record so comprehensive that we can reconstruct minute details of daily life in ancient Rome with remarkable accuracy. And yet, when it comes to the megalithic platform at Baalbek, when it comes to explaining how the foundation beneath their own temple complex came into existence, the Romans suddenly fall silent in a way that seems almost deliberately evasive, as if they arrived at this site in Lebanon, surveyed the massive stones already in place, recognized that they were looking at something they couldn't replicate or even fully understand, and collectively decided that the safest course of action was to simply not talk about it, to build their temples on top of this inexplicable foundation, and pretend that the real mystery lay not in the stones beneath, but in the glory of the structures they erected above. Roman engineers wrote extensively about the Colosseum, documenting the innovative use of concrete and the sophisticated system of underground passages and elevators used to bring gladiators and wild animals into the arena. And they left detailed accounts of how the Pont du Gard aqueduct was constructed, including the methods used to transport and position the massive stone blocks that form its arches. And they even recorded techniques employed in building the Pantheon's magnificent dome, which remained the largest unreinforced concrete dome in the world for over a millennium. But when it comes to the foundation at Baalbek, a foundation that would have represented an engineering achievement surpassing anything the Romans themselves accomplished, we find nothing in their records. No descriptions of construction methods, no attribution to specific engineers or emperors, no boastful inscriptions claiming credit for moving stones that weighed as much as naval vessels. Which suggests either that the Romans didn't build this foundation at all, or that they recognized it as something so far beyond their capabilities that claiming credit for it would have been laughably transparent. An obvious lie that would undermine their reputation as master builders rather than enhance it. The timeline of Baalbek's construction presents a puzzle that becomes more confounding the more closely you examine it. Because the site shows clear evidence of multiple building phases spanning thousands of years, with the megalithic platform representing the oldest layer, followed by what appear to be Phoenician or pre-Phoenician modifications, then Greek-era additions, and finally the Roman temple complex that tourists visit today. And this layering suggests that successive civilizations built upon what they found, rather than creating something entirely new. Each generation adding to a site that already held significance, already possessed foundations that couldn't be replicated with contemporary technology. And so they did what seemed practical under the circumstances. They incorporated the ancient megalithic blocks into their own construction plans, treating these impossible stones as a gift from the gods, or the work of giants, or some other explanation that allowed them to benefit from the platform's existence, without having to explain how it came to be there in the first place. Archaeological dating of the megalithic platform remains frustratingly imprecise, with estimates ranging from the Roman period back to the Bronze Age or even earlier. And this uncertainty exists partly because the stones themselves don't contain organic material that can be carbon dated, and partly because the archaeological evidence has been disturbed and complicated by thousands of years of continuous use and modification of the site, with each successive civilization removing or building over evidence left by their predecessors, creating a palimpsest of construction where the earliest layers are the most difficult to read and the most important to understand. Because if the megalithic platform truly predates the Roman occupation by millennia, as the differences in construction technique and the complete absence of Roman documentation suggest, then we're forced to reconsider our assumptions about what civilizations existed in this region during the Bronze Age or earlier, and what they were capable of,
accomplishing with tools and knowledge we assumed they didn't possess.
Local legends and oral traditions surrounding Baalbek offer explanations that academic archaeology tends to dismiss as mythology. Stories that attribute the site's construction to giants, to the biblical figure of Nimrod, who supposedly commanded the stones to be placed through divine or magical power, to pre-flood civilizations that possessed knowledge lost in some ancient catastrophe. And while these legends clearly can't be taken as literal historical accounts, they do represent a persistent cultural memory that the site is extraordinarily ancient, that it predates known historical civilizations, and that its construction involved capabilities that seemed superhuman or supernatural to the peoples who came later and found these massive stones already in place, already ancient, already mysterious. The consistency of these giant builder legends across different cultures, separated by vast distances and long periods of time. Similar stories appear in connection with megalithic sites in Peru, in Egypt, in various locations across Europe and Asia, suggests either that these stories represent independent mythological explanations for structures that ancient peoples couldn't explain through normal human agency, or that they preserve some kernel of historical truth about a period of human civilization that existed before our written records begin, a period when construction on this scale was possible through methods we've since forgotten or never properly understood. And dismissing these legends entirely as primitive superstition seems increasingly problematic when we consider that the stones themselves are real, are present, are demonstrably there despite our inability to explain how they got there using the technological capabilities we attribute to ancient civilizations based on our current understanding of human development and the tools available at various points in history. The pattern of inherited megalithic sites appears throughout the ancient world, with later civilizations consistently building on top of or incorporating stones placed by cultures that came before them. And this pattern suggests a troubling possibility, that the civilizations we study and admire, the Greeks and Romans and Egyptians, whose writings and art and architecture form the foundation of our understanding of the ancient world, were themselves building on the remnants of something earlier, something they couldn't fully replicate, something that had already passed into legend by the time their own cultures reached their peak. And if this is true, then our timeline of human civilization might be missing entire chapters, entire civilizations that rose and fell, leaving behind only their most durable monuments. Stones too massive to be moved or destroyed by later peoples, who could only marvel at them and build around them and invent stories to explain their existence. At Sacsayhuaman in Peru, massive megalithic stones fitted together with precision that matches or exceeds what we see at Baalbek form the foundation of fortifications that the Inca incorporated into their own construction. But the Inca themselves, according to their own traditions, did not claim to have built these megalithic foundations, instead attributing them to people who came before, to a previous age when such construction was possible. And the Spanish conquistadors who encountered these structures in the 16th century immediately recognized that the megalithic stones differed fundamentally from the Inca construction above them, noting in their chronicles that the massive, fitted stones appeared to be the work of a different civilization, with different capabilities and different knowledge. Though, of course, the Spanish attributed this to demons or fallen angels, rather than considering the possibility that human history might extend back further and encompass more than the biblical timeline accepted as absolute truth. The archaeological establishment's resistance to pushing dates earlier than conventional timelines allow, to seriously considering the possibility that sophisticated civilizations might have existed before the beginnings of recorded history, reflects partly legitimate scientific caution about making claims without sufficient evidence, but it also reflects institutional inertia and the very human tendency to dismiss evidence that doesn't fit comfortably within existing frameworks of understanding. Because acknowledging that megalithic sites like Baalbek might be thousands of years older than currently estimated would require rewriting textbooks and revising cherished theories about how civilization developed and where it began, and what technological capabilities existed at various points in human history. And this kind of fundamental revision encounters resistance not because the evidence against it is overwhelming, but because the implications are unsettling. To academic disciplines that have built entire research programs and career trajectories on assumptions that would need to be questioned or abandoned if we took seriously the possibility that advanced construction capabilities existed far earlier than our current models suggest. The example of Göbekli Tepe in Turkey demonstrates both the potential for radical revision of historical timelines and the resistance such revision encounters. Because when this site was first properly excavated and dated to approximately 9,600 BCE, roughly 6,000 years before Stonehenge and well before the supposed invention of agriculture and settled civilization, the findings challenged so many assumptions about what hunter-gatherer societies could accomplish that many archaeologists initially dismissed the dates as errors or suggested that the site must represent some kind of anomaly, an exception that proved the rule rather than evidence that the rule itself might be wrong. And yet, the dating has held up under repeated testing, and the site clearly demonstrates that people we categorized as primitive were capable of quarrying, transporting, and erecting massive T-shaped pillars decorated with sophisticated carved reliefs, accomplishing architectural feats that supposedly weren't possible until civilizations developed the organizational structures and specialized labor forces that agriculture made possible. Which means either that Göbekli Tepe is indeed an inexplicable anomaly, or that our entire understanding of the capabilities of pre-agricultural societies needs radical revision. The absence of written records from whoever built the megalithic platform at Baalbek might seem like an insurmountable obstacle to understanding their civilization and their capabilities, except that this absence assumes writing is the only way that advanced knowledge can be preserved and transmitted, when in fact the stones themselves might represent a different kind of record, a deliberate, message, encoded not in symbols on clay tablets or ink on papyrus, but in the sheer impossibility of the construction itself, in the demonstration of capabilities that would force future generations to recognize that whoever created these monuments possessed knowledge and power beyond what we imagine possible for ancient peoples. And perhaps that was the point. Perhaps the builders understood that empires and languages and writing systems would come and go, that everything they might write would eventually crumble to dust, or be burned by invaders, or simply be forgotten as languages evolved and changed. But that stones weighing 800 tons, fitted together with precision that can still be measured millennia later, would endure as permanent testimony to their existence and their capabilities. A message that doesn't require translation, because its meaning is embedded in its physical impossibility, according to our assumptions about what ancient technology could accomplish. The megalithic structures scattered across the planet, from Baalbek to Pumapunku in Bolivia, with its precisely cut stones featuring complex interlocking joints, from the massive blocks in the walls of Cusco to the enormous stones of the Great Pyramid's foundation, from the enigmatic structures at Nan Madol to the precisely fitted walls of ancient Japanese megalithic sites. These monuments share common features that suggest either widespread cultural contact we haven't discovered evidence for, or independent development of similar advanced construction techniques by different civilizations, or possibly a single earlier civilization that influenced or gave rise to later cultures in different parts of the world. And while mainstream archaeology tends to favor the independent development explanation, attributing similarities to the universal constraints of working with stone and the limited number of ways to solve certain engineering problems, this explanation becomes increasingly strained when you consider not just that different cultures built with massive stones, but that they achieved similar levels of precision in fitting those stones together, similar sophistication in earthquake-resistant design, similar ability to work with weights that challenge modern equipment, as if they were all drawing on a common reservoir of knowledge about how to accomplish these feats, rather than independently inventing the same advanced techniques in isolation from one another. The question of why advanced civilizations would leave almost no written records, but massive stone monuments as their primary legacy, leads to uncomfortable speculation about catastrophes that might have destroyed softer materials while leaving the most massive constructions intact, about deliberate choices to encode knowledge in stone rather than in more fragile media, about the possibility that what we consider advanced, writing, literature, detailed historical records, might not have been priorities for cultures that measured advancement differently, that valued different forms of knowledge and different ways of preserving it. And while this speculation necessarily remains speculative, given the absence of direct evidence, it's worth noting that our own civilization produces enormous amounts of written material that likely won't survive more than a few centuries before degrading beyond recovery, while the massive concrete foundations of our largest buildings might endure for millennia after everything else we've created has turned to dust. Which means that future archaeologists, examining the remnants of our civilization thousands of years from now, might find themselves in a similar position to us examining Baalbek, looking at foundations that seem impossibly massive and sophisticated, while lacking any written records to explain how or why they were built. And perhaps they too would struggle to reconcile the evidence of advanced engineering with the absence of documentation, would debate whether our civilization could really have possessed the capabilities demonstrated by our largest constructions, would resist pushing our timeline earlier, even when the evidence suggested our achievements preceded the development of technologies they assumed were necessary for such accomplishments. The pattern that emerges from examining Baalbek alongside other megalithic sites worldwide suggests a troubling lacuna in our historical understanding. A missing chapter, or perhaps several missing chapters, where civilizations rose to levels of technological and organizational sophistication that we associate with much later periods, only to collapse or decline for reasons we can only guess at. Climate catastrophes, wars, plagues, social upheaval, or some combination of factors that wiped away everything except the most massive and durable of their constructions, leaving later civilizations to inherit sites they couldn't replicate and could only wonder at, incorporating these ancient foundations into their own building projects while inventing myths and legends to explain their existence, because the truth was lost along with everything else from that earlier age. This possibility that human civilization has not followed a simple, linear progression from primitive to advanced, but has perhaps cycled through rises and falls, through periods of achievement and subsequent collapse, through ages when certain types of knowledge and capability existed, followed by ages when that knowledge was lost. This possibility troubles our comfortable narrative of progress and improvement, challenges our assumption that we stand at the pinnacle of human achievement, looking back at inferior predecessors, and suggests instead that we might be looking at the remnants of civilizations that accomplished things we still struggle to match, that possessed knowledge we've had to rediscover, or haven't rediscovered yet. And the implications of this possibility extend far beyond academic debates about construction techniques and dating methods, reaching into fundamental questions about human nature and the sustainability of civilizations, and whether the path we're on now, with our assumption of continuous progress and our confidence that we're smarter and more capable than everyone who came before, might be leading us toward our own collapse and our own transformation into a mystery for future archaeologists, who will stand before our greatest constructions and wonder how we managed to accomplish what their own technology cannot replicate. Just as we now stand before Baalbek's trilithon and wonder the same thing about whoever placed those impossible stones in their impossible positions thousands of years before we arrived, with our cranes and our confidence and our complete inability to explain what should not exist, but manifestly does. Which leads us, inevitably, to question not just how the stones were moved, but what other explanations we've been avoiding, what other possibilities we've dismissed because they don't fit within our accepted framework of ancient capabilities, and whether perhaps the answer lies not in finding better conventional explanations, but in being willing to consider that the ancient world might have possessed technologies and knowledge that we've categorized as impossible, simply because we haven't found the evidence for them yet, or because we've been looking for the wrong kind of evidence, expecting ancient peoples to have developed along the same technological pathways we've followed, when perhaps they found entirely different solutions to the problems of moving massive stones and building enduring monuments. Solutions that left no trace except the monuments themselves. And that realization opens doors to possibilities that conventional archaeology has kept firmly closed. Possibilities that we'll need to explore if we're ever going to understand not just how the stones at Baalbek were placed, but why their placement was so important that someone undertook the monumentally difficult task of moving them in the first place, and what they knew or possessed that made such seemingly impossible feats not just possible, but necessary to preserve for future generations who might otherwise forget that such things could be done at all. The moment you suggest that ancient civilizations might have possessed technologies fundamentally different from what we find in the archaeological record, technologies that worked according to principles we haven't rediscovered or have categorized as impossible based on our current understanding of physics and engineering, you risk being dismissed as a fringe theorist, or worse, relegated to the realm of pseudoscience and ancient alien speculation. And yet, this dismissal itself reveals something interesting about how we approach historical mysteries. Because we're willing to accept that ancient peoples accomplished things we cannot replicate, but we're unwilling to seriously consider that they might have accomplished these feats using methods that don't fit neatly into our evolutionary model of technological development, as if the only acceptable explanation is that they achieved the impossible using primitive versions of the tools and techniques we use today, just with more patience and more workers and more time, rather than considering the possibility that they might have understood principles of physics or material manipulation that we've either forgotten or never discovered in the first place. Principles that would seem like magic or divine intervention to us, just as our smartphones and airplanes would seem supernatural to someone from the Bronze Age. And this willful limitation on what we're willing to consider as possible explanations for ancient achievements reveals more about our own intellectual constraints than about what ancient peoples could or could not have accomplished, given sufficient knowledge and motivation. The idea of acoustic levitation, using sound waves to manipulate the position and movement of objects, exists not in the realm of science fiction, but in actual scientific laboratories, where researchers have successfully used precisely tuned sound frequencies to levitate small objects, demonstrating that acoustic pressure can indeed counteract gravitational force under the right conditions. And while current acoustic levitation technology can only handle objects weighing grams rather than tons, the principle itself is sound, proven, and suggests that with sufficient understanding of resonant frequencies and wave interference patterns, it might be theoretically possible to reduce the effective weight of much larger objects, making them easier to move or position. And this isn't wild speculation, but rather an extrapolation from demonstrated physics. Yet, when ancient texts from various cultures describe gods or advanced beings who could make stones light, or who moved massive blocks through the power of sound or song or properly intoned words, we immediately categorize these accounts as mythology, rather than considering whether they might be describing, in the limited vocabulary available to ancient observers, technologies that worked through principles we're only beginning to understand in our modern laboratories. The Egyptians have legends of priests who could move blocks through the utterance of specific sounds. The Tibetan texts describe monks levitating stones through the use of drums and horns tuned to particular frequencies. The Incan traditions speak of a time when stones could be made to float through the application of some plant extract combined with rhythmic sounds. And while we cannot take these accounts as literal technical manuals, the consistency of the theme across widely separated cultures suggests either that this is a universal mythological motif that humans independently invented to explain things they didn't understand, or that these stories preserve distorted memories of actual technologies that worked through manipulation of sound and vibration in ways that seem incredible to us now, but might have been well understood by cultures that approached the problem of moving massive stones from a completely different direction than we've taken, with our emphasis on mechanical force and hydraulic pressure and brute force solutions to engineering challenges. The relationship between megalithic sites and acoustic properties has been documented extensively in recent years, with researchers discovering that many ancient stone structures exhibit unusual resonant characteristics, amplifying certain frequencies in ways that seem deliberate rather than accidental. And while mainstream archaeology interprets these acoustic properties as incidental byproducts of construction, or perhaps as features designed to enhance ritual ceremonies and religious experiences, the precision with which some of these structures amplify specific frequencies, often in the range of human vocal production, or the resonant frequencies of the types of stone used in construction, raises questions about whether the acoustic properties were, in fact, central to the purpose of these structures, rather than peripheral features. Whether the builders understood something about the relationship between sound, stone, and structural stability that we've dismissed as irrelevant to the practical challenges of construction. The Great Pyramid of Giza, for example, has been shown to resonate at frequencies that match the resonant frequency of the Earth itself, a correspondence that seems unlikely to be purely coincidental, given the precision with which the structure was built. And the sarcophagus in the king's chamber, when struck, produces a tone that corresponds to the resonant frequency of the chamber itself, creating standing waves that anyone inside the chamber can feel as well as hear, suggesting that whoever designed this structure understood acoustic principles well enough to engineer specific resonant effects into a building made of millions of tons of stone. And if they understood acoustics to that degree, is it really so implausible to consider that they might have understood how to use acoustic principles not just to create interesting sound effects, but to accomplish practical tasks like reducing the effective weight of massive stones during transport and positioning? The concept of working with stones through methods that don't involve cutting or abrading them in the conventional sense opens another avenue of inquiry that challenges our assumptions about ancient construction techniques. Because the geopolymer theory, proposed by materials scientist Joseph Davidovits and supported by various forms of chemical and microscopic analysis, suggests that at least some ancient megalithic blocks might have been cast rather than carved, created by mixing crushed limestone with various binding agents to create a slurry that could be poured into molds and would harden into solid stone, indistinguishable from natural limestone except under detailed chemical analysis. And while this theory remains controversial and hotly debated within the archaeological community, it would explain several puzzling features of megalithic construction, including the absence of tool marks on many blocks, the extremely tight fits between stones that seem impossible to achieve through carving and trial fitting, and the presence of what appear to be air bubbles and other anomalies in some blocks that are more consistent with cast material than with natural stone. And if this theory has any validity, it would mean that the challenge of moving massive blocks becomes instead a challenge of material science and chemistry, requiring knowledge of which minerals and binding agents would create durable artificial stone, rather than requiring the ability to transport weights that challenge modern equipment. Though, of course, This explanation introduces its own mysteries about where ancient peoples would have acquired such sophisticated chemical knowledge and why this knowledge was subsequently lost so completely that we've had to rediscover the principles of concrete and artificial stone through our own research, rather than finding detailed ancient descriptions of the processes involved. The absence of appropriate tools at megalithic sites represents one of the most persistent anomalies in conventional explanations of ancient construction. Because if you're going to quarry, shape, and fit together massive blocks of limestone or granite or other hard stone, you need tools capable of cutting or abrading that stone, and the tools need to be harder than the stone itself to be effective, which means that working granite requires tools made of extremely hard materials like diamonds or modern carbide cutting surfaces. Yet, the civilizations we credit with building megalithic structures supposedly worked with copper and bronze, metals that are actually softer than many of the stones found in ancient construction. And while copper tools can certainly work limestone through patient abrasion, they would be nearly useless for shaping granite or other hard igneous rocks. And yet, we find megalithic granite structures like those at Pumapunku in Bolivia, that show evidence of sophisticated cutting, including internal right angles and perfectly flat surfaces that would challenge modern stoneworking equipment. All supposedly accomplished with tools that shouldn't have been capable of producing such results. Which leaves us with several possible explanations. Either the builders had access to harder tools that we haven't found in the archaeological record, because they degraded completely or were made of materials we haven't considered. Or they used techniques that didn't require hard tools in the conventional sense, working stone through chemical dissolution or thermal stress, or some other method that wouldn't leave the kind of evidence we're looking for. Or the structures are younger than we think and were built with more advanced tools than we attribute to the civilizations we credit with their construction, none of which are particularly comfortable conclusions, because they all require us to revise significant parts of our understanding of ancient capabilities and technological development. The notion that human civilization has experienced cycles of rise and fall, with knowledge and technology accumulating during periods of stability and being lost during periods of catastrophe and collapse, challenges the linear, progressive narrative that underlies most of our thinking about history. But this cyclical model might actually explain more about the archaeological record than the simple progression from primitive to advanced that we've constructed based on limited evidence and assumptions about how societies must develop. Because we know from our own historical experience that knowledge can be lost. The Romans made concrete that was superior in many ways to modern concrete, incorporating volcanic ash in ratios that created material more durable and resistant to seawater erosion than anything we produced until the 20th century. And yet, this knowledge was completely lost after the fall of the Roman Empire and had to be painstakingly rediscovered through modern research and analysis of surviving Roman structures. And if knowledge of concrete production could be lost during a period for which we have extensive written records and surviving examples of the technology in use, how much more knowledge might have been lost during earlier collapses of civilizations that left behind less extensive records and fewer examples of their technologies in action? The examples of lost technologies multiply the further back you look. Damascus steel, produced through processes that created blades of extraordinary strength and sharpness, remains incompletely understood despite modern metallurgical analysis and attempts at replication. Greek fire, the Byzantine Empire's secret weapon that burned on water and couldn't be extinguished by conventional means, was lost so completely that we can only guess at its composition and production method. Various Roman architectural techniques were forgotten and had to be rediscovered during the Renaissance. Even relatively recent technologies like Stradivarius violin construction involve elements that modern craftspeople cannot fully replicate, despite access to the original instruments and sophisticated analytical tools. And if we've lost or imperfectly preserved technologies from civilizations within our historical record, civilizations about which we have extensive written documentation and physical evidence, then the possibility that much earlier civilizations possessed significant technological knowledge that was subsequently lost becomes not just plausible, but almost inevitable. The resistance to considering alternative technologies and explanations for megalithic construction stems partly from legitimate scientific caution about proposing theories without sufficient evidence, but it also reflects a kind of institutional conservatism that punishes researchers who stray too far from accepted narratives. Because proposing that ancient civilizations might have possessed sophisticated knowledge of acoustics or chemistry or other principles that we haven't found direct evidence for in the archaeological record risks professional reputation and academic credibility. And this creates a situation where even researchers who privately acknowledge that conventional explanations don't adequately account for what we observe at sites like Baalbek are reluctant to publicly advocate for alternative theories that might be closer to the truth, but would mark them as fringe theorists or pseudoscientists. And this intellectual conservatism, while understandable in terms of maintaining academic standards and avoiding the acceptance of unfounded speculation, also has the effect of limiting the range of questions we're willing to ask and the types of evidence we're willing to seriously consider, creating blind spots in our understanding, where we simply refuse to look at certain possibilities because they don't fit within the framework of what we've decided ancient peoples could or could not have known. Which means that technologies or knowledge systems that don't match our expectations might remain invisible to us, not because the evidence doesn't exist, but because we've trained ourselves not to see it, or have categorized it as mythology or religious symbolism, rather than recognizing it as potential descriptions of actual practices and capabilities. The comparison between ancient capabilities and modern impossibilities should give us pause, should make us question whether our assumption that we're more advanced than ancient civilizations is actually justified when we consider what they accomplished versus what we can accomplish. Because we can indeed split atoms and sequence genomes and send robots to Mars, but we cannot replicate the construction of the Great Pyramid using the tools attributed to the Egyptians, cannot recreate Damascus steel using medieval techniques, cannot move 800-ton stones with Bronze Age technology, cannot explain how pre-Columbian cultures in South America achieved platinum metallurgy, when platinum requires temperatures above 1,700 degrees Celsius to melt, temperatures that shouldn't have been achievable without modern equipment, cannot account for the precision of ancient astronomical observations made without telescopes or modern mathematics. And this list of things we cannot do, cannot explain, cannot replicate, grows longer the more closely we examine ancient achievements, which suggests either that ancient peoples were extraordinarily lucky in repeatedly accomplishing things that should have been impossible, with the knowledge and tools we attribute to them, or that our attribution is wrong, our understanding incomplete, our assumptions about ancient capabilities based more on what we think they should have been able to do, given our models of technological development, rather than on what they actually demonstrated they could do through the physical evidence they left behind. The question of why alternative theories about ancient technologies are dismissed as pseudoscience rather than seriously investigated reveals interesting things about how scientific consensus operates and how institutional structures can inhibit as well as advance knowledge. Because while maintaining standards of evidence and requiring reproducible results before accepting extraordinary claims is essential to scientific progress, there's a difference between healthy skepticism and reflexive dismissal, between demanding good evidence and refusing to look at evidence that doesn't fit predetermined conclusions. And the current state of megalithic archaeology often seems to fall on the wrong side of this line, treating any suggestion that ancient peoples might have possessed knowledge or capabilities not found in the conventional archaeological record as inherently suspect, rather than as hypotheses to be tested and investigated, which means that potentially valid lines of inquiry remain unexplored, not because they've been thoroughly tested and found wanting, but because they've been dismissed a priori as impossible or unworthy of serious investigation. The academic frameworks within which researchers operate reward incremental advances within established paradigms and punish those who challenge fundamental assumptions, creating a system where questioning whether ancient peoples might have understood principles of acoustic levitation or advanced chemistry or other technologies we haven't attributed to them is professionally risky in ways that proposing minor refinements to accepted theories is not. And this structure of incentives and risks means that even when evidence pointing toward alternative explanations accumulates, the threshold for overturning established narratives remains extraordinarily high, requiring not just strong evidence, but a critical mass of researchers willing to risk their credibility by taking such evidence seriously. And until that critical mass is reached, alternative theories remain marginalized, regardless of how well they might actually explain the observations we're trying to account for, trapped in a kind of limbo where they're too controversial to be accepted, but too well supported by physical evidence to be completely dismissed. And sites like Baalbek sit at the center of this controversy, massive and undeniable, and completely resistant to explanation through conventional theories, waiting for us to develop either the intellectual courage to seriously consider alternatives or the conventional evidence that would finally put the mystery to rest by showing definitively how 800-ton stones were moved and positioned with Bronze Age technology. And until one of those developments occurs, we remain stuck in the uncomfortable position of knowing that something impossible happened, but being unable or unwilling to accept any of the possible explanations for how it was accomplished, leaving us to wonder whether the problem lies in the evidence we have or in the assumptions we bring to interpreting that evidence, and whether perhaps the real breakthrough will come not from finding new physical evidence at ancient sites, but from questioning the intellectual frameworks that have prevented us from seeing what the evidence we already have might be telling us about ancient capabilities and the technologies they might have possessed that don't fit comfortably into our evolutionary model of human development. Technologies that might have seemed as natural and obvious to them as smartphones and GPS seem to us, but which have been lost so completely that we can only glimpse their existence through the impossible achievements they enabled and the confused legends that preserve distorted memories of capabilities that ancient peoples once possessed and we have not yet recovered. Capabilities that allowed them to move mountains, to reshape landscapes, to create monuments that would endure for thousands of years as permanent testimony to knowledge we've spent millennia trying to rediscover. And perhaps that knowledge is not as lost as we think. Perhaps it's encoded in the structures themselves, in the precision of their construction and the sophistication of their acoustic properties, and the sheer, impossible scale of their component stones, waiting for us to develop the right framework for understanding what we're seeing, to ask the right questions about what ancient peoples knew and how they knew it, to seriously consider possibilities we've been trained to dismiss as impossible. Because until we're willing to do that, until we're willing to look at Baalbek and the other great megalithic sites of the ancient world with genuine openness to explanations that challenge our comfortable assumptions about the past and our place in the long arc of human civilization, we'll remain trapped in our ignorance, unable to explain what ancient peoples clearly accomplished, unable to replicate what they demonstrably built, and unable to escape the ironic conclusion that for all our modern sophistication and technological advancement, we are, in some fundamental ways, less capable than the supposedly primitive peoples who came before us and left behind monuments to mock our assumptions about progress and our certainty that we understand the full range of what is and is not possible when it comes to moving stones that weigh as much as warships and fitting them together with precision that would challenge our finest engineers even today.